Here we've got a question where two forces act simultaneously on some unknown mass, which is shown by the yellow circle on the picture. One of the forces is 100 newtons, and its direction is said to be 53 degrees. So when it just says 53 degrees, we assume that's standard notation from the positive x-axis. So that angle right in there is 53 degrees. The second vector measures 120 newtons, and it's at 135 degrees from the positive x-axis. So this vector over here is 120 newtons, and its angle is 135 degrees from that positive x-axis. And we want to take those two vectors, which we'll label F1 and F2, and add them together. We're trying to find the net force, and the net force is defined by the sum of the forces, adding the vectors together. So we want to go F1 plus F2, and because we're adding vectors together, we want to add them together tip to tail. So let's do that. Okay, let's start with vector F1. And we're going to take vector F1. We're going to add tip to tail. So from the tip of F1, we're going to put the tail of F2. There's my vector diagram. Now let's label them. Here's F1, and there's F2. Notice the tip of F1 touches the tail of F2, so we say that that's tip to tail. And we want to figure out the resultant. So I'll put the resultant in a different color. So notice my resultant points from the start of my diagram towards the finish. And you can barely see the little arrowhead here. I'm going to make it a little more prominent. This is the answer. This is what F1 plus F2 equals, and we're calling this F net. Now we can see we've got a triangle there, so we're going to use the trig method to start. In the second video, I'll do this question again using the component method, and then you can decide which one's more appropriate for the question based on your understanding. Now let's, again, label some angles. We know that vector F1 from the horizontal, this little angle right here, is 53 degrees. Now let me just move F1 over here so we can do this properly. All right, this little angle right here from the horizontal is 53 degrees, as stated in the original problem. Now it's always important when you're doing the trig method, whenever you start another vector, here's the tail of the next vector. Draw an imaginary little set of coordinates, an XY axis, so that you can draw some angles and label some references there. Now remember, F2 was 135 degrees from the positive x-axis. Now since this horizontal dotted line represents the x-axis, and that entire flat line is 180 degrees, 180 minus 135 makes this little piece of it 45 degrees. Now, if we have 53 degrees down here at the start of F1, there's an alternate interior angle rule that says this little angle up here. See how they're alternate on and interior to these two parallel lines, this dotted one down here, this horizontal one down here, and this horizontal one up here? We'll use that rule a lot. I call it the Z rule. So 53 degrees here is the same as 53 degrees right there. So there's my triangle. And if I get rid of all the clutter, the interior angle on this triangle is 45 plus 53. So that interior angle makes 98 degrees. So we're going to solve for that triangle, but I want to get rid of all the clutter first to make it a little bit clearer. So there's my triangle. Now clearly that's not a right triangle, so we can't use basic trig. We can't use Pythagoras. We're going to use the cosine law. Now I know to use the cosine law because I've got an angle in between two known sides. I've got the 120 and the 100 newtons straddling this angle. So what is the cosine law? What does it look like? Cosine law starts like Pythagoras, c squared equals a squared plus b squared, but then we make an adjustment for the fact that it's not a 90-degree triangle. Minus 2ab cos capital C. Now really all you have to know for this cosine law is that whatever you choose for a and b, the nice thing about the cosine law compared to the Pythagorean theorem is there is no longest side, there is no hypotenuse. The only rule is that a and b have to be on either side of angle C, which is the case we have. Doesn't matter which one's A and which one's B, we know the 100 and the 120 are on either side of this angle. So the angle in between A and B, in other words, is 98 degrees. So now we simply go ahead and fill it in. So I'm going to say A is F1, B is F2, minus 2A, B, and cos of 98 degrees. And when I crank all that through and take a square root, I end up getting 166.6 newtons. So that's what F net must be. My net force, this side here that we're looking for, if we round it off to 3 significant figures, is 167 newtons. So we've taken care of the magnitude of the force. Now what about the direction? We need to figure out an angle. So let's see if we can get this little angle right here. Now first of all, we're going to switch. We're going to switch to the sine law. So I'm going to go sine theta, that's our unknown, divided by its opposite side, and its opposite side is 120, equals sine of our known angle divided by its opposite side, which we've just determined is 167. Now I'm going to use 166.6 to avoid any rounding errors. But sine theta is sine 98. Remember, that's just some decimal number on your calculator, times 120, all divided by 166.6. All right, making some room so I can complete the question. When I'm trying to find the angle, remember the last step is to go second function sine, or sine inverse of both sides. So on the left, the sine cancels off. I'm left with just theta. And on the right, if I went sine 98 degrees times 120 divided by 166.6, I should get 0.713. But I want to do the sine inverse of that number. And when I do, I end up getting an angle of 45.5 degrees. So this little angle right in here is 45.5 degrees. Let's label that. Now remember, we also have another angle. The 100 Newton force makes an angle with the horizontal of 53 degrees. So this entire angle up to the green line would be 53 plus 45.5. And it's important to recognize that when you're trying to figure out the final direction of your vector, I can't simply use this 45 degrees that I've determined in my sine law. It's not quite that simple, because then how do I put it into words? I would say that it's 167 newtons at an angle of 45.5 degrees from the 100 Newton force, which is already 53 degrees from the x-axis. It's too complicated. So you always want to make your angle with respect to either a horizontal line or a vertical line. Now, since we know the two angles that meet up to that horizontal line, let's figure out that entire angle all the way down to here. So I'm going to go 45.5 plus 53, and I'm going to get an entire angle of 98.5 degrees from the x-axis. So again, let's remove some clutter here. Now, if I was just to redraw just that vector, this is what it looks like. I know the value of it. It's 167 newtons. We've already figured that out. And we've just figured out that this entire angle is 98.5 degrees. Now, it's often more convenient to do the other angle, the one that's less than 90 degrees. So if this entire flat line represents 180 degrees, if I go 180 minus 98.5, I should get my answer of 81.5 degrees. So the angle with respect to that horizontal this one right here, is 81.5 degrees, or rounded off 82 degrees. Notice it's swinging to the north from the west line. So it's 82 degrees north of the west line.